Hello friends, this is very important question. If r vector is given to you in this format, then we have to find the absolute value of the cross product of these two, the first derivative and the second derivative of r. And secondly, we need to find the scalar product of these. So let's start with the solution, but before that, let's introduce the scalar product of the vectors. The scalar triple product formula is for the vector a, b, c. Its scalar product in the formula format is the cross product of a and b having its dot product with c. And then also we have this matrix format. And third one, if this scalar product is equal to 0, then vectors are coplanar. Coplanar means the vectors lies on the same plane, right? So for this exercise, I am going to use the formula for this. So let's start with the solution. We have the r vector to be equal to this, and we need to find the absolute value of these two vectors. Let's find out what is the first derivative of r with respect to the scalar variable t. Okay, let's derivate this with respect to t. A vector is a constant vector and derivative of the unit vector is 0. So we have its derivative to be negative of a vector sine t I vector, right? Plus, derivating this with respect to t, we have again a vector is a constant vector, derivative of sine t is cos of t, and then writing j vector. Plus, we have again a vector to be the constant, and also tan alpha is constant here, and derivating only this t, that is 1, and writing k vector here. I hope it is okay to you, right? Okay, we can take this a vector outside common, and we have here negative of sine t I vector plus cos of t j vector plus tan alpha k vector. So this is your first derivative of r vector, and now finding the second derivative of r vector with respect to the scalar variable t, and we need to derivate this now. What is double derivative of r vector? It is the derivative of the first derivative of r. Yes? Okay, so that will be equal to a vector, okay, derivating sine t, that is minus of cos t I vector, then derivating cos t is negative of sine of t j vector. Tan alpha is constant, its derivative is 0, and also the derivative of k, that is a unit vector, is also 0. So third term is 0 over here, skipping this. So we have the second derivative to be this. Let's take the cross product of these two now. So for the cross product, we need to find the determinant of, okay, writing the components of first derivative of r, right? Okay, writing now the components for this double derivative. We have minus a vector cos t minus a vector sine t. So we have the I vector over here, and taking the cross product of these two with negative sign in between. 0 multiplied with a vector cos t is 0 minus a sin t multiplied with a tan alpha, that is a vector square sin t tan alpha. That's it. Negative sign, writing j vector over here, and now taking the cross product of these two, and then writing k vector and cross multiplying these two. So we have here minus a vector square sine of t tan alpha I vector minus a vector square cos of t tan alpha j vector, and if I take a vector square outside of this bracket, I will be having the identity sine square t plus cos square t is 1. So it is 1, and writing k vector. So it is actually a vector square k vector. And now taking the absolute value for this. So the absolute value for this cross product is equal to the square root of the square of the first component. So this is a the power 4 sine square t tan square alpha plus the square of the second component. So this is a the power 4 cos square t tan square alpha, the square of the third component, that is a the power 4, right? This all is under the square root. So this is equal to the square root of, okay, let's take a vector the power 4 common, and we have sine square t. Also I am going to take tan square alpha common from these two terms, and then plus a vector the power 4. So that is equal to the square root of, this is nothing but 1, and a vector the power 4. This is now tan square alpha plus 1. Taking this outside of the square root, so we get here a vector square. And what is 1 plus tan square alpha? It is equal to the secant square alpha. Yes, this is secant square alpha. So the square root sign disappear from this. It is now secant alpha. So this is a required solution for the absolute value of the cross product of these two vectors. And now remaining to find the scalar product of these three vectors. Already we have found the first derivative and the second derivative. And now finding the third derivative of r with respect to the scalar variable t. Okay, so this is minus a vector derivating cos t. We have negative of sin t, and then minus a vector derivating sin t. We have cos of t, and here j vector. Okay, let's take the scalar product. The scalar triple product of these three vectors is equal to the cross product of first two vectors and then having its dot product with the third vector. It is having the dot product with the third vector. Okay, what is the cross product of these two? We have calculated already. That is this one. We have calculated the cross product of these two vectors to be equal to this. So let me write all this. So we are having its dot product with this vector, and its value is this one, a vector sin t I minus a vector cos t j. Alright, having the dot product of I vector with I vector, that is 1. The dot product of same vector is 1. J dot j is also 1, k dot k is also 1. But if we take the dot product of different unit vectors, then that will be equal to 0 always. Similarly for the other ones. For the same vectors, we have the dot product to be equal to 1. For the different vectors, we have dot product to be equal to 0. Right? Okay, let's use this while taking the dot products. When taking the dot product of I vector with I vector, we get 1 and multiplying these two. So we have a vector cube sine square t tan alpha. Taking the dot product of I vector with j vector, that will be 0. So there is no need to multiply these two. Just take this value to be as 0. Then taking the dot product of j vector with I vector, again this is 0. And taking the dot product of j vector with j vector, that is 1. And we need to multiply these two also. So this is plus a vector cube cos square t tan alpha plus third component, having the dot product of k vector with I vector 0, having the dot product of k vector with j vector is also 0. So there is no need to multiply the coefficients. So it is 0. So now taking a cube tan alpha common from these two terms, we get sine square t plus cos square t inside the bracket, and because of the identity, that is equal to 1. So this is equal to a vector cube tan of alpha to be the required solution for the scalar triple product of these three vectors. Alright, thank you.